Hi, I'm Tom English, and this lesson is about exponents. And there are rules for how to handle exponents, just like we had the order of operations for handling multiplication, division, addition, subtraction. There's order of operations, so to speak, for exponents as well. Let's start with the basics though with exponents and recognize that when we're using an exponent, the number that we're raising to a power is called the base. And we can only do some of these rules if the base is the same. Okay, in this case we're saying the base is 5, the exponent is 2. And again, by the exponent means that's how many times we're going to use this base as a multiplier. So in this case, 5 raised to the second power means 5 times 5, or in this case the answer would be 25. Now, for the first rule that we want to remember is that if we end up with an answer, let's say we had x is equal to a to the minus 2 times, I don't know, b plus c. Okay? The rule says is that if you still have a negative exponent or you have parentheses, you're not there yet. The answer is not complete. So that's the first rule that I want you to remember. The second rule that we want to talk about is that if we have a negative exponent, we need to invert the problem, or invert the, let's say we had x to the negative 2. That, I said, is not complete answer. We need to change that to a positive exponent. And if we have a negative and it's in the numerator, we invert it, put it in the denominator. If the negative exponent is in the denominator, we put it up into the numerator. So in this case, x to the minus 2 would be equal to 1 over x squared. If we had a squared b to the minus 3, well, again, the negative, we want it back in the denominator, so that final answer would be a squared over b to the third power. So just think about it. If I've got a negative, it needs to be reversed. When we multiply the base with different exponents, for instance, if we have x squared times x cubed, we're multiplying, it's the same base, and we multiply these two, then we're going to add the exponents. So this would be x to the 2 plus 3, or x to the 5th power. So remember, multiply, we're going to add the exponents. The opposite of that is if we're dividing. Let's say we had x to the 5th divided by x cubed. We're dividing this case, it's the same base, so we just subtract the exponents, and that's equal to x to the 5 minus 3, or in this case, x squared. Okay? So when we're multiplying the same base, we add the exponents. If we're dividing the same base, we are going to subtract the exponents. And we can have more complex issues than these. Let's say we've got a to the 3rd, b to the 4th, c squared over a squared c. Okay? How do we simplify that? Well, where do we have the same base? We've got a cubed divided by a squared. That would be a to the 3 minus 2, or a. b to the 4th stays that way, but we have what? c to the 2nd divided by c. So that would be c to the 2 minus 1, or c. Okay? We multiply, we add the exponents, we divide, we subtract the exponents. How about if we raise a power to a power? For instance, if we have x squared and we're going to cube that. In this case, we're raising a power to a power, so what we do is multiply the exponents. So this would be x to the 2 times 3, or x to the 6th. Okay? Let's complicate it. Let's say we had a cubed, b squared, c to the 4th power, and we're going to raise all that to the 3rd power. Okay? We treat each one separately. A cubed raised to the 3rd power. Again, when we're raising a power to a power, we multiply the exponents. So that would be a to the 9th. B squared raised to the 3rd power would be b to the 2 times 3, or b to the 6th power. And c would be what? 4 times 3, so it would be c to the 12th power. Okay, just one more rule, and that's that any base, it doesn't matter how complex it is, but if it raised to the 0 power, that is equal to 1. Let's show a reason for that. For instance, if we said before, if we're dividing, for instance, if we're dividing x cubed by x squared, what did we do? We subtracted the exponents, didn't we? So that would be equal to x to the 1 power. However, if we had x cubed divided by x cubed, we're going to have what? X to the 0 power. And what is one thing divided by the same thing? We know that's equal to 1. So no matter what the base is, if we're raising it to the 0 power, it's going to be, the answer is going to be 1. Let's do a real funny one here. Let's say we got x squared y cubed over m to the 5th, n to the 7th, and we want to raise all that to the 0 power. Well, forget all this in here. You see it raised to the 0 power? Your answer is 1. Okay? Went through that kind of quick. I think the key here is that as you do the problems, again, like anything else, get some experience with them, you're going to find they're really pretty easy. Again, where most students have difficulty is multiplying. You add, dividing, you subtract. But if you're raising a power to a power, you multiply the exponents. Okay? Let me also ask if this is not clear. If anything on any of these videos is not quite clear to you, I'd really appreciate an email from you. My email address is tom at the website, which is mathtutoring4free.com. These lessons are for your benefit, and if there's anything that I'm not covering clearly, please let me know. I'll either modify the lesson, or maybe it's something that I haven't had a lesson on. I'd be more than happy to create something. But I want this to be for you, so let me know what your questions are, your frustrations, what do you need help with, and when you let me know, I'll try to react as quickly as possible and get some help on the way. Thank you.